Now let's look at another way that we can use pieces, corresponding parts of congruent triangles to prove that the triangles are congruent. We've already done side, side, side. Now we're looking at side, angle, side congruence postulate. So what does that mean? Also known as SAS postulate. Here's the statement. If two sides and the included, what's included mean? Whatever between, whatever we're talking about is between the other things we're talking about. So we're talking about two sides and the included angle. So we're talking about an angle that is between the two sides we're talking about. So we have two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Okay? We'll look at some proofs here in just a minute. So we have two examples, regardless of how they're drawn, they're marked. We have triangle ABC, use that a lot, and triangle LMN. And notice that we've marked side AC is congruent to side LN. Okay? We've also marked that side BC is congruent to side MN. And that angle C is congruent to angle N. Now notice where angle C is. It's between the two segments. Okay? It's the included angle or the angle between the two segments. Notice where angle N is located. It's the angle between the two segments that are mentioned. Okay, by the SAS postulate, having given this information, we can simply say that triangle ABC is congruent to triangle LMN. Now, in order to get our CPCTC, there's that abbreviation again, we need to know CPCTC lined up straight, corresponding parts, triangle ABC, put it over triangle LMN. Now what's corresponding? What points are corresponding? A corresponds to L, B to M, C to N. And that leads us to say angle A is congruent to angle L, angle B is congruent to angle M, angle C is congruent to angle N. And segment AB is congruent to segment LM. Segment BC is congruent to segment MN. And segment AC is congruent to segment LN by CPCTC. That thing keeps showing up. This is how we would apply the side, angle, side, or the SAS postulate. Now let's do an example of a proof. We would use the SAS, or side, angle, side congruence postulate to prove two triangles are congruent. Here's a very common type of picture or figure that you'll be shown in tests, and well, in real life it's not uncommon for you to solve these types of triangles. We're given a figure that has two triangles in it with a common point, triangle ABC and triangle DEC. Okay? And we're given that C is the midpoint of segment AD. Okay? And BE. Well, let's look at what our given is. C is the midpoint of segment AD. Well, if C is the midpoint of segment AD, what does that mean? C is the midpoint. That means it bisects that segment. If you bisect the segment, you cut it in half, creating two congruent segments. So that means that AC is congruent to DC. Why do I say DC? Because A and D are corresponding. Okay? Now, it also says that C is the midpoint of not just AD, but also BE. So if it cuts segment BE in half, then it also creates two congruent segments. So segment BC is going to be congruent to segment EC. So that gets us our side and side. Now what we need is an included angle between those two sides. Do we have an included angle between those two sides? Yeah. We have angle ACB and angle DCE. What do we know about those two angles? What is their relationship? They're vertical angles. They're non-adjacent angles of two bisecting segments or lines. Or are those known as? They're simply known as vertical angles. So by the vertical angle theorem, we know that those two are congruent. Wow, so we have already set up our side angle side. Side angle side, side angle side. So let's prove it. Number one, what are we going to do? C, midpoint, AD, chunk, Y, given. What's the result of C being the midpoint of AD? Well, we just said that AC, segment AC, is congruent to segment DC. And again, why did I say DC? Because A and D are corresponding. In fact, let's put that up there so we know and see what it says. A, B, C, and triangle D, E, C. They're going to be corresponding. A corresponds to D. Okay? So we're going to set it up that way. Now, why? Well, definition of midpoint. Okay? So there's one of our sides, isn't it? Now, let's just go ahead and work ourselves around because the next thing we want is an angle. Well, what do we know? We know that angle ACB is congruent to angle DCE. And again, we use the corresponding setup. Why? Vertical angle theorem. Alright? So there's our angle. All we need is another side and we're good to go. So what are we given? We're given that C is the midpoint of segment BE. Why? Given. What does that given tell us? That given tells us that segment BC is congruent to segment EC. Why? Because the E and the B are corresponding. Why? Same reason as up above. Definition of midpoint. So what does that lead us to? Oh, by the way, there's our side. Look at that. SAS. SAS. We got it. Therefore, quite enough done. Triangle A, B, C is congruent to triangle D, E, C. Why? Because of the SAS postulate. Now, let's extend that just a little bit, and let's say that they also wanted us to come in and say, wow, we also would like for you to prove that segment AB is congruent to segment DE. So, we'd simply come down here and say, okay, number 7, tie this in, and we would say segment AB is congruent to segment DE. Why? CPCTC. Because we proved the two triangles congruent, then the corresponding parts of those two triangles are also going to be congruent, all the corresponding parts. We could come along and say, wow, we need to prove that angle A is congruent to angle D. Okay, same thing, CPCTC. We need to prove that angle B is congruent to angle E. Okay, same thing, CPCTC. Very useful. Okay, this is an application of the side angle side postulate to prove that two triangles are congruent, and then of course we can state that all the corresponding parts of those two triangles are also congruent.